We are starting stream again. Looks decent. Okay, cool. Okay, so we were doing top interview questions. So let's just get back into it. Hmm. Oh, I actually did look at this problem behind your back, haha, and I was at the right on the right track, but not really in a way. Um, yeah, so I'll just bring my notebook. Okay. So the question is, let's zoom it in. Yeah, so the question is, given an input array, generate an output array so that each element is the product of all the other elements in the array at that index, except like basically product of all the elements in the array except the element at that index. Okay, so yeah, I had to write down the solution. So, sorry. So what I was coming up with was something like this. So say this is your array. So let's make, so I was thinking about left max arrays and right max arrays. That gave me the idea of left product and right product arrays. So what that was going to be is at each index you keep the product of that number with the previous number basically. So it's 1, 2, 6, 12, sorry, 1, 2, 6, 24, and the right one would give you 4, 12, 24, 24. So now this actually did not work well because I was not able to come up with the answer anyhow. So this didn't make any sense. So what the actual answer was, it was actually, just scrub that off. Yeah, so what the actual answer was that instead of keeping the product of that element, the element at that index and the previous element, do something like this. So keep the first element as 1 and then keep this product. Similarly here. So you don't keep, sorry, my bad. So you keep the product of these two. For this one, it's going to be 4. 4 and 3 is 12, 24. So if you actually see what these elements are, is that this is a product of all elements except this one, and this one is a product of all elements except this one. So let me show you something else. A, B, C, D. This is 1. This was A, B, A, B, C. And on the other side you had 1, D, C, D, B, C, D. And if you actually multiply these two, you get B, C, D, A, C, D, A, B, D, and A, B, C. And isn't that what you wanted? A is missing, B is missing, C is missing, and D is missing. So you actually get this as your correct answer if you do it like this. Why is this happening? It's just sort of a pattern, I guess. That so basically up till this point you kept all these elements somehow, and for the other array up till this point you kept these elements. So, and that's true for each, each such instance. So that ends up giving you the correct answer. The other challenge is doing it in constant space. The answer to that was actually, so of course you need one array, right? To return the answer. So you keep that array and then you multiply that with uh, one constant value instead of keeping an array. From here you multiply with 1, then you multiply this with the um, last element. This becomes that element. Then you multiply this. I mean, basically you only multiply with this C, and for while iterating, C is 1 over here. C is 1 over here. In step number 2, it becomes C into D. In step number 3, it becomes D into C. And then in step number 4, sorry, 4 it becomes D into C into B. So that way this array itself becomes an answer. So we're going to take the second approach and create a vector of size, be an answer of size nums dot size, the value 1 for I equals 0, I equals for int I equals 1, I is less than nums dot size, I plus plus. Oops, my bad. Here we go. Scroll up to see. Okay, this is what we want in the outputs. So we want answer I to be set equal to answer I minus 1 times nums I, right? And then we create a variable, oh, we already created C. So for int I equals nums dot size minus 1, I is greater than equal to 0, I minus minus ans I. So you're going from the right now, equal to ans I times C. You could just written times equal, and C equals C times equals nums I. Return answer. Should take care of all cases except size 0, I guess. And okay, output is not what I had expected. Answer This one answer equal to answer times num I. It's 1, it becomes 1 times 1 times 2. Let's see what our answer is in the middle. Let's see which loop is wrong. So it's 1, 2, 6, 24, that's right. Then it should be 24 num I will not update nums I anyway, right? So C becomes sorry, I think it's going to be I think it's fine. Start the end, we times it by C, and then we make C as D, which is 8, sorry, 6. Oh, yeah. Output is what? What did I just do? Did I? One sec. I think I screwed up over here somewhere. So you don't include that, you do this plus 1, you start from 0 and you go till the end minus 1. Right, that way you get 1, 1. Sorry, start 1 still. You get 1, 3, 12. 12? How is it 12? I'm screwing something up horribly. Okay, sorry. Let's just look at our code and look at our logic and then do it. So first was going to be 1, and then it was going to be A, which was ans I minus 1 times num I minus 1, right? So it was going to be 1, 1, 2, 6. Yeah, so this is fine. Then it has to be this answer times C, and C is going to be, yeah, so now this should be fine. Yeah, might fail for like nums having size 1 or 2 or something, but okay, passed, that's great. Cool. Moving on, kth smallest element in a BST. I think I've seen this somewhere before, but I might have not been able to do it. Okay, in a binary search tree, if I write a function to find the kth smallest element, k is always valid. Hmm. Hmm. Okay. Sorry, did I hide the question? Okay, so the first thing that comes to mind is if you just do an in order, it is in order. Bu- 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 uh, pre-order traversal. Okay, so in order, I guess. So basically, traverse the left, right, sorry, left, center, right, and when you reach when you've processed a node, you do I plus plus. So you like basically increase a counter, and when you start that counter with 0, and when that counter is equal to k, means you have found your answer. So yeah, that's that. So so let's say we have a counter int count. That's my thinking. I think that is a possible solution. Might be a possible solution. I am unaware of the complication that might come with it, but I'm gonna try writing it down anyway. Should I give more thought to different solutions before trying out what I have in mind already? I am not sure. Hmm. Ooh. Hmm. 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 I show you the code? Nope, I did not. I am dumb. Yeah. Sorry, was that? Okay, no problem. So basically, um, uh, just called the helper function, and what it did was, if it's null, you just return. If it has a left child, then you call, like, iterate on the left child and then count plus plus. And if count is k, which means you have checked the kth element just now, then your answer is this. Else you count plus plus outside, I mean not else, in any case you do count plus plus for the current node, and then if that is equal to k, then that is your answer, and otherwise you do it on the right child, and if count is k, then the right child is the answer. So it did work for this case, but I don't know if it worked for all cases. Yeah, output 2 expected 3. So it's 5, 3, 6, 2, 4. Store that. 5, 3, 6, 2, 4. That makes no sense. See what is the way they're doing it. 3, 1, 4, null 2. Non-null children's double nulls are not mentioned or something. Null, null 1. So input is 3, output is 2, etc. is 3, 1, 2, 3. So event count was, I hate that they made it premium. Um, Count was 0, started the root. It was left child, yes. Go left, go back in. If it has left child, yes, go back in. If it has a left child, yes, go back in. If left is not null, um, oh, if it is null, then count plus plus. If count is equal to k, count is right now 1 over here. If you have a right child, that's not right. Oh no, that's okay, I guess. Then you don't have a right child, you come out to 2. You ah you do count plus plus again. But this one is this for the left child? But the left child did for itself as well. So that's the problem. Um, so I guess you don't need to do this essentially. Because each node is going to do it for himself when they reach themselves anyway. So the question said, what if the BST is modified often and you need to find the kth smallest element frequently? How would you optimize the kth routine? Hmm. So say basically it's about maintaining some other value. maybe just updating. How would you find the kth smallest frequently, optimally? Maybe to keep it simple, maybe you can keep something like a counter of number of nodes at each to the left and right, like how many left children a node has and how many right children a node has. So it says like 5, 3, 2, and you have to find the fourth number, right? Sorry, not like this. Say it says this node has 3 on the left and 2 on the right, and you find the fourth largest number. So since fourth, so kth smallest, yeah, fourth smallest number. So basically, you know that the smallest three numbers are to the left of this node. So it's going to be definitely to the right. And then there are two nodes on the right in total. So it will be, so this tree is something like this, let's say. And so this would say something like 0 or 1 or 1 or 0. Um, so depending on that, you decrease k firstly because you moved one step already. So if you're at that element, that will be your answer. So k is now 3 in a way. No, not really. So k is 4 minus 3, 1, and then you decrease 1 when you move here. And when k becomes 0, sort of, then that's your answer. Coincidentally, I wrote this as k as well. But let's see what solution they gave. Okay, it's on. Let's see if they. Ah, same thing, I guess. Um, I think it's extra space, uh, sort of. Small optimization, I guess. Never mind. Iterative, that's PFS, I guess. They were discussed last week? Hmm. That's like literally this thing. Just keep two data structures. Screw it. Anyway, okay. Oh, this might have been a copy paste of my crazy JavaScript code. Oh no, it's not. Oh, I did it the other way this time. Oh, okay. Hmm. Yeah, this is really. Maybe you should just remember what this is. Like how much to rotate, like what what position to move to using this variable. I just removed the variable. It's like, oh, you take more memory now. Anyway, I think this is generally this might be asked because a friend did get asked this question, but you probably will be able to figure it out in some time during the interview itself, or you can at least if tell the logic instantly enough, which is obvious. You should be fine. Find the duplicate number given an array of numbers containing numbers. Prove that at least one duplicate number must exist. Prove. Assume that there is only one duplicate number. Find the duplicate number. You must not modify the array. You must only use constant space. Your complexity should be less than O(n) square. There is only one duplicate in the array, but it could be repeated more than once. So you can't modify it. And ah, so this is sort of part of the trick. I mean, not part of the trick. They're saying they have numbers between 1 and n, and one number might be repeated multiple times. Um, so you can't just, yeah, it's not that obvious. And it should be less than O(n) square, and you can only use constant space, so you can't really sort of sort, nor can you use hash maps because it's constant space, and you must not modify the array, so you can't sort the array itself. So, oh, sorry again, I'm showing you the question. So what would this be like? Hmm. So let's just write something down. So let's say you have 1, 2, 3, so on and so forth, and you have x, and then you have another x, so on and so forth, and then you have n minus 1 and n. This is your array, right? So this number is at least duplicated somewhere in the array. Less than O(n) square means you can't just check for each number if it already exists in the array or not. Ah, just remembered. So, oh, but you can't modify the array. Hmm. Hmm. So you can't modify the. If you could have modified the array, you could have used the turning the numbers negative trick. So when you're given something of a requirement that your array has elements 1 to n, and also I mean the size is n and the numbers are between 1 and n, and so those basically lie between 0 and n minus 1, which is your index range in a way, you know. So you can just set the value at that index as negative. So basically mod you set mod of 1 as negative of whatever, and when you come Um, actually, one. And when you're trying to set an index as negative and it's already negative, which means you already tried setting it negative, which means uh, the number you're trying to use it to set it negative is your answer. But since we can't modify this array anyway, so that was a pretty useless discussion. Although it might help you in the actual question. Okay, so. Hmm, hmm. Excuse me. Excuse me. Bye bye. Can you like get out or something? Oh, okay. It's an infinite scale. Never mind. Whee. Okay. So, so you can't use extra space, and it has to be less than n square. You can't update the array, and you can use constant space only. So let's think of binary maybe. So this is 1 and this is 2. Um, hmm. Hmm. If a number is duplicated, what do we know? Not really anything. The sum of the array could still be the same as if the number was not duplicated. I mean, you don't know how many times it's been duplicated, so basically 1 and 3 could be replaced by 2 and 2, and the sum would be same. The product, on the other hand, might definitely be different. But can you really tell By how much? So the product otherwise would be n factorial times x. Let's not call it x, let's call it d. So times d. But right now it could be anything from n factorial times so I mean for 1 to n plus 1 it would be n plus 1 factorial, and right now it could be anything from n factorial times d to d times n plus 1. So I mean, but this could still be like n factorial times d. So we don't really know what it's going to be. How is going to be the product? Complexity should be less than O(n) square. Hmm. Do we have hints? I would like to use hint. There is no hint. Hmm. Do you guys have any hints? Hmm. Any clue about what it should be? Hmm. I am having absolutely no clue. Do we have topics? Tags? Show tags? No. Okay. So basically, it says you can only use constant space. So let's say we can say one or two variables. So what can those variables say? What properties can those variables have? So let's look at all the operations that we can do on an array in a single pass. We can either find the sum of all the elements, which would be anything from n plus 1 times n plus 1 times d to n into n plus 1 by 2 plus d. So we don't really know anything about that. We talked about the product already, which could also be very vague. But let's look at the bit wise. So the bitwise product of all the values. That does make sense. Damn, I have no clue. I don't want to waste everybody's time. The first two approaches do not satisfy the constraints. Pigeon. Oh, okay. Cycle detection. Yeah, okay, sorting is obviously one, and yeah, set or map is one. Cycle detection. Am I the right? Yeah. Okay. We can show that the constraints of the problem imply that the cycle must exist. Each pair, okay, each item will point to an index that exists, right? Therefore, the list can be traversed infinitely, which implies the cycle. There is a cycle. Additionally, because 0 cannot appear as a value, can be part of the cycle. Therefore, traversing the array in this manner is equivalent to traversing a cyclic linked list. To see the algorithm in action. What? That made absolutely no sense, mate. Hmm. So this is weird. So all this saying is just check for loop. I don't like the question. Let's move on. Foursome is a retarded question. Let's move on. Kth largest element in an array. Okay. Find the kth largest element in an unsorted array. Note that kth largest element in the sorted array, not the kth distinct element. Oh, hmm. One sec. So straight up what I'm thinking is sorting the array and then iterating through it and keeping a counter that updates only when the consecutive elements are not the same, and when that counter is equal to your k, just return the current element. Zero, 1 don't match. C plus 1. So if C equals k, return nums I. Now nothing happened, then return nums dot end. I might have to stop the stream now.